So, speaking of the OXC parser, I find it funny that it seems like that project in Vite itself started in the same way, where you were just creating a thing to for a side project, and I think Boshin, the guy behind OXC, was just
Mm.
creating a reference implementation of a parser in Rust. So, how do we get from there to this is now like that one little Lego block at the bottom of the big structure that is Void Zero?
Yeah, I think a lot of it is me when I was thinking about, okay, we need to write our own bundler for Vite, and what do we base the bundler on top of? And we looked at, so there are multiple ways of thinking about this, right? So rewriting in JavaScript, no, because it's going to be too slow. So we want to do it in a compiled native language, and we looked at Go. There's already ESBuild, which is a great project. I think the downside of ESBuild is in order to achieve the maximum performance, ESBuild is architected in a way where many different concerns are layered across as few AST passes as possible. So its minification logic is actually spread across multiple passes. And it's not like minification is minification. It's like in the same AST pass, you would see some branches dealing with minification, some branches dealing with transforms, and that making external contribute making like basically extending ESBuild in a reasonable way quite difficult because you're going to be adding more branches in these AST paths, and it's going to be very difficult for us to manage it. Evan Wattis is obviously brilliant, and he has everything in his brain, and he can improve ESBuild with this architecture because that's his intentional decision. But we just feel like it's not a good foundation for us to, if we want to ever extend on top of it. And also, we do want to make each part well isolated so that people can use it as individual dependencies instead of having to opt into the whole thing all at once. So then we turn to Rust. And so Fortune actually also contributed to RSPack at ByteDance. And there are some technical decisions in RSPack that made it essentially too late for them to switch to OXC because it's already built on top of SWC for a very long time before OXC was even usable. But I have been keeping an eye on OXC for a very long time. And I think it is important that for the new tool chain to be based on something that kind of learns from a lot of the things that we've done in the past. Because it's when Borschen worked on OXC, he had contributed to Rome/Biome in the past as well. They had to contribute to SWC and deal with SWC during our spec development as well. The team at Web Infra has a lot of experience dealing with Rust language toolchains and systems. And I think he distilled a lot of the learnings into the development of OXC initially as a proof of concept. And when it became a bit more production ready, it showed that, okay, all these things did pay off. Both SWC and OXC are written in Rust, but there's a pretty significant performance advantage that OXC has. And there are some other design decisions that's a bit more detail. For example, when using this language toolchain to support the bundler, there are a lot of semantic analysis that we have to do. For example, like determining whether this variable is referenced in this current scope, or is it shadowing outer variable, or is it used and exported by and used in another module? A lot of these kind of things, you have to do the analyzation, right? So in JavaScript, most of the parsers just like stops at giving you the AST and they're done. So when we are dealing with, say, I think Babel probably provides a bit more infrastructure for that, but in my own work, for example, in the Vue compiler, we have to do a lot of these semantics analysis ourselves. I think in Svelte, Rich Harris has also written quite a few tools centered around this. But I believe that should be a first-party concern of a language toolchain. It actually comes with a semantic analysis API that allows you to query these information after the parsing is done. Because as you parse, it also collects and stores this information already. So you don't have to do the traversal yourself to figure out this information. You can just ask. So this is also slightly different from, say, the way SWC works. In a way, I don't want to bash SWC because it is the first JavaScript Rust toolchain. And I think it served its purpose really well. A lot of people are still using it. It's great. But I think there are things we can learn from it, learn from the past efforts. And we believe OXC is just a better foundation if we want to build more ambitious features on top of it. Yeah, so Rodan essentially started out with OXC as the base. And so far, we are happy that the performance is turning out to be living up to our expectations.
Something I've always admired about your approach to projects is that very iterative style. So I remember when I first discovered Vue, you were just making the transition from Vue 1 to Vue 2, introducing virtual DOM, learning a lot of lessons from React. And that always struck me, and I feel like you've had a pattern doing that over the years. So I'm curious to tie into the sort of incremental approach that you are taking now. What have you learned from projects like Biome and Rome, for example, who have tried to tackle somewhat similar problems, but maybe from a different angle? And SWC probably is like in this same category. They're like trying to tackle some performance problems. What are the like big lessons and takeaways and things that you're trying to do differently than those projects might have tackled?
I think in terms of the end vision, it's very obvious that Voice has a lot of similarity to what Rome wanted to do. I think there are two major differences. First is we decided to work on the toolchain for Voice mostly because we already have Vite serving as a point of convergence, right? If we don't have Vite as the leverage, then the chance of success will be much slimmer, right? And Rome really didn't have anything like that. They started out with something that's completely from scratch and with the hope of. So for Rome, I think the biggest challenge is just going from 0 to 1. How do you make people adopt it? And they started out with a formatter, which kind of makes sense because formatter is probably the least intrusive piece of task that's in the overall development flow. In a way, it's completely decoupled from everything else. That makes it easier for people to switch to and adopt. The downside of that is it's also not a strong leverage to have because it's not really related to the rest of the tasks people are doing. So I think the angle where you get the adoption from, this is more like a strategic difference, I think. Another more technical difference is I think Rome's implementation or Biome's Rust code base was initially designed to be more intended for an IDE use case scenario. They focused a lot on the IDE story. They essentially built something, they use something called CST, concrete syntax tree, because they want to preserve the shape of the original code as much as possible, and they want to be resumable and more error resilient. A lot of this are great for IDE use cases, but not necessarily best if you want to do the other tasks, for example, get the fastest possible transforms, and also basically be able to use the AST for multiple tasks along a pipe. So I think Boschen could probably share more insights on this front, but I think the difference between the AST and CST was also a major reason where Boschen was like, we don't really want to do that. OXC. Yeah, but I think it's unfortunate that Rome didn't get to actually keep going beyond what it is now. But I think it still showed people that it's possible to write high quality tooling for JavaScript in Rust because a lot of people are happy with Biome as a formatter nowadays. And it's also part of the reason why we're not in a hurry to work on formatter because it already fills that gap. We will probably eventually have an OXC based formatter just for complete sake, but for us, that's just going to be down the road.